Hi dear, we have come to the last part of the extraction of metals from ores. Okay, so already we are done this concentration of ore, metals of low reactivity and metals of medium reactivity. Okay, today we will see about the metals of high reactivity. Okay, so metals of low reactivity usually it obtained in the form of sulfide ores. Okay, sulfide ores can be easily extract from the sulfide ore. It is easy to extract the metal simply by roasting, that is heating in the presence of oxygen. Okay, next metals of medium reactivity is available in the form of sulfide ore as well as carbonate ore. Okay. Sulfide ore, as usual, by roasting we can get the metal. From the carbonate ore we'll go for the calcination process, so the oxides of the metals will be reduced to metal by heating with carbon, right? Carbonate ores are obtained by heating with the carbon. So here we are using the carbon as a reducing agent. Okay, from that pure metal can be obtained. Okay, then the last one is your metals of high reactivity. Okay, that we are going to extract the metal only using the electrolysis of molten ore. Okay, electrolysis of molten ore. Why we are not go by this reduction of oxide using the carbon means, because here this highly reactive metals, these metals have more affinity to oxygen than carbon. Okay, so it is not so it cannot be reduced using the carbon. Okay, why metals high up in the reactivity series are not obtained from their compounds by heating up with carbon? Because carbon cannot reduce the oxides of sodium, magnesium, calcium and aluminum. It cannot reduce the oxides of sodium, magnesium, calcium, aluminum to the respective metals, because these metals have more affinity to oxygen than carbon. Okay, it's highly combined with the oxygen than carbon. Hence these metals are obtained only by electrolytic reduction. Okay, electrolytic reduction. So what has been by electrolytic reduction? Electrolytic reduction means by passing the electric current. Okay, so electrolytic reduction means an ionic compounds containing both cation and anion bonded to each other through strong electrostatic force of attraction, that we know. Okay, so these ions cannot be separated by simply heating the compound. Okay, so it has to be separated one. If we heat more and more, it may decompose. Okay, decomposition may happen. Okay, but dissociation of the ions will not happen. Okay, so how to dissociate the ions? When we pass electricity, it can dissociate in the molten state, right? When electricity is passed in the molten compound, that is why it is mentioned the electrolysis of molten ore. Okay, so it should not be in the solid form, it should be in a molten form. Okay, liquid form, then only a movement of the ions will happen. Okay, when heating the compound, when the electricity is passed in the molten compound, the metal ion coming in contact with the cathode accept the electron from it. Okay, because metals are positively charged, right? Electropositive in nature, so they will have extra electrons, so these electrons will be accepted by the cathode, right? And it gets reduced. Okay, and it gets reduced. This electricity induced reduction is known as electrolytic reduction. Okay, this electricity induced reaction is known as electrolytic reduction. So how we will carry out this process means, highly reactive metals are obtained by the electrolysis of their molten chlorides. Usually the ores will be of molten chloride form. Okay, obtained by the electrolysis of their molten chlorides. These metals are when the electricity is passed, the metals are deposited on the cathode, the negatively charged electrode, whereas the chlorine is liberated at the anode, the positively charged electrode. Okay, the reactions are, so how will you obtain the sodium from its sodium chloride means in the molten state NaCl at cathode, at cathode Na ionic form, Na plus is there, so it has one electron, right? So it loses one electron and form a metal, sodium. Okay, and in cathode you will have Cl minus, 2 electrons are there. It will release the 2 electrons and it chlorine form, okay, molecule form. Chlorine gas will be liberated at this anode. Okay, next they ask for this aluminum oxide also. Okay, how will you obtain the aluminum from its aluminum oxide? Okay, so at cathode aluminum loses 3 electron and form a aluminum atom, and here in the cathode the oxygen get 2 electrons and become oxygen atom. Okay, so the again this oxygen atom is not stable, it readily combines with another oxygen atom to form a oxygen gas. Okay, oxygen molecule. Okay, this is how the electrolysis of highly reactive metals takes place. Okay, okay, so whatever we have extracted already, we have done this concentration of ore also. In that the gangue will be removed. Gangue is nothing but the impurities. Okay, even though it is removed at this place, that whatever we obtain the metal is not pure. Okay, it may contain some impurities. Okay, so that we have to remove. Okay, that is called refining of metals. Okay, refining of metals. Most widely used method for refining impure metals is electrolytic refining. Okay, so what is the process going here means, we will take again electrolytic refining means we are going to use electricity. Okay, this anode whatever we are extracted from the when the extraction process, this impure metal is made this anode is made up of this impure metal. Okay, some salt solutions will be there for conduction. Okay, this cathode is made up of a pure thin metal. Okay, thin strip of metal. Okay, on passing the electric current, this will dissolve in this solution, and the whatever insoluble impurities will deposit here as a anode mud. Okay, impurities will deposit insoluble, other things will be soluble in the solution, and the metal will be attracted towards the negative. Okay, so the pure metals will be deposited on the cathode. Okay, this is the process in the refining of metals. Okay, so impure metals, that is extracted metal, is taken as an anode strip. Okay, anode, and a thin pure metal strip is taken as a cathode. Okay, the salt solution of the metal is taken as an electrolyte. What is the electrolyte uses? The salt solution of that metal. Okay, on passing the current through the electrolyte, the pure metal from the anode, because whatever we extracted that metal is, this anode is made up of that metal. Okay, so on passing the current, the pure metal from the anode dissolves into the electrolyte. Okay, it mixes with the electrolyte. That whatever is mixed, then equal amount of pure metal from the electrolyte is deposited on the cathode. Okay, the soluble impurities go into the solution, whereas the insoluble impurities settle down at the bottom of the anode and are known as anode mud. Okay, so that's all with the extraction of metals from their ore. Okay, thank you.